This is Greater Team Model Academic Enhancement School, GMAT 41. You are welcome to our statistics class. Before I introduce this course, I want to say this to you, please. Wherever you are watching this, listening to this, you have no reason, absolutely whatsoever, not to make an A in this course. I want to make this very clear once again, that you learn with GMAT 41, you are certain that this course is going to be A. We are not just talking about A, but we are looking at smashing 90 and above. Yes. When we are done teaching you, you would see, you will believe that yes, in GMAT 41 here, we apply all the research tools at our disposal to give you the best. And you will believe that this course is really below you. You can do it. On the board here, we are starting with frequency distribution. Of course, it's a concept that most of us may have actually come across. When talking about frequency distribution, it's important for us first to know what frequency is. A frequency can be defined in different dimensions, both from science and of course you talk about statistics here. What does statisticians say about frequency? It is defined as the number of times a variable or variate value occur in a distribution. Sometimes I might just give you a distribution like, okay, the age of students in a given class, you could have something like, okay, there are some people that are 20, 30, 23, 25, 15, 18, 17, you know. All those things are variate values. They are values of the variable. How many times do a particular variable occur in the distribution? That is what we refer to as what? Frequency. Now, these values are usually put in table. They are usually presented in table. Of course, statistics is a very important research tool. When you gather your facts and other things, you present them in a format that interpreting it will be quite easier and good to look at. Now, one of these tools we use in data presentation in statistics is frequency table. And so when you know the frequencies of a given distribution, you present it in what? In table. Hence, frequency table is a table which shows the value of the variables in a given distribution. A variable is also referred to as variance. Take note of that. If you hear a variable, we also call it what? A variance. And what does it mean? It is any entity, any parameter, anything at all whose value can change, can vary. Which means if you hear variable, it's not constant. The value of that thing can change anytime. Now, this includes measures such as weight, height, number of students, yield of crops, age. All these things there are variables because they can take different value at different times. Having introduced this concept, we want to start with forms of variable. There are two of them. We talk about the discrete variable and of course the continuous variable. Talking about the discrete variable, this is any variable that takes integral value. By the word integral value, we mean it has a specific value as a whole number. Maybe a distribution may be given to you, have something like 2, 8, 9, 1, 0, 6 whole numbers. Those values, any variable that has a value like that, we refer to it as a discrete what? Variable. An example of such is something like number of people, age. Have you ever heard something like the number of people is 22.7 people? I mean 7 people. It doesn't make sense. Or maybe in terms of age, I am, for some of us who say that I am 7 years and a half, or I'm 23 years and a half. Where is that half coming from? You are 23 years. Once you're not up to your birthday, the day you were given birth, of course, it means you are below the age you are thinking of. So that is a discrete variable. And now we talk about continuous variable. A continuous variable is a variable which assumes continuous value within the range of the least and the highest observation. Usually in continuous variable, the value can take either integral values or it can take something like decimal values. Now I want to talk about integral values just like in the case of discrete. A continuous variable could be something like maybe 5 to 10. You know, each of these, like 5, like 10, you're seeing that is a discrete variable because it's a whole number. But if you now put it in range form between the least and highest observation, it becomes continuous. You can have something like 11 to 15. So this is a continuous variable. Something like a decimal number, that fraction is also a continuous variable. You can have like 2.5, it's continuous. This value is not specific. 2.5 is 2 plus 0.5. Telling you is a value between 2 up to a highest point of 2.5 there. You can have something like 2.1, 2.2, 2.3 and the rest of them. So these are the two types of variables, and you're going to encounter them in the study of statistics. Of course, when we'll be talking about probability distribution, you'll meet all of them. We'll talk about the semi-1 Poisson's probability, the binomial probability, the normal distribution, and the rest. Let us look at presentation and analysis of statistical data. But first, we start by asking ourselves, what do we mean by data? Data simply refers to information collected to be analyzed and interpreted. I'm going to give you an example to help you understand what the concept of data is. In most cases, this information are obtained from what we call field work. Let me ask you a question. Have you ever heard the word questionnaire? Questionnaire. Where someone could come with maybe some papers, where you have questions on the paper, and then the person would just distribute it to some persons or maybe students and say, please help me and check this paper. All right, kind of tick some things. Some places you could see they ask a question and then you have options like yes, no, not applicable. You tick whatever you think. Now the person gets this information and analyze the information. It is used to solve a lot of problems. I don't know if you get me, in the society. The person will analyze the information and then interpret it. And if that thing has to do, or the information collected has to do with trying to solve a particular problem in the society, he or she may provide the observations, his or her discussion, the finding and the conclusion that the person wants to make from all the analysis. Now let us think of these. Now we have this pandemic all around, COVID-19, and that we are encouraged to put on nose mask, all right, in order to prevent us from issue of maybe transmitting the disease easily and all the things, or maybe contracting it. Now you come to a particular place and there are some people with the nose mask, other people are not. Someone may decide to run a survey on that, interpret the data collected. Just construct a questionnaire with some questions there. Maybe why are you not putting on nose mask? Is it because maybe you have an ailment, a sickness that is preventing you from putting on nose mask? It could be maybe asthmatic people who need, air often. It might not really be too ideal to always have their nose covered. Could it be that you feel that, the disease is not real, like some people say that, and why are you not putting on nose mask? Okay, those that are using, what do you think are the benefits of putting on nose mask? Once you construct good questions on that and then share the paper, people will take, they will answer. I don't know if you're getting me. You will get this information and then make your analysis. The response will help you to know what people, those set of people or community feel or their view about COVID-19 and the issue of having their nose mask on. This is what we mean by data collection. Then you interpret and give your result. Now the question we want to look at now is, what statistical tools do we use for data analysis and interpretation? We have them on the board here. You have frequency table, histogram and bar chart, frequency polygon, cumulative frequency curve, also called OGIF. This one that has a pair of scissors-like shape, that intersect. All these tools, we use them for statistical analysis. Now, we want to start first by looking at a frequency table. Already in the previous video, we learned that frequency table is a table that is used to represent a variable and the number of times that variable appears in a distribution. A frequency table can either be for grouped data or ungrouped data. If it is for ungrouped data, a comprehensive frequency table will have what we call the item, that is the variable in question you're trying to analyze, and then the tally and frequency. So sometimes the tally, we just choose not to put it where you draw lines like this, up to 5 we cross. So most times we don't include that. What are for grouped data? If it is for grouped data, more information are required, and we have them on the board here. First, the item, the variable itself, where in that case it's presented in interval form. You can have something like 5 to 10, 11 to 15, 16 to 20 and the rest, in interval form. We've already talked about continuous variable before now. Then we have the frequency column, we have the lower class boundary, the upper class boundary, the class mark, the less than cumulative frequency, the greater than cumulative frequency. All these are the things you include when you're talking about grouped frequency distribution table. And sometimes for a group frequency distribution, you could have something like percentage frequency also included. We are going to look at each of these statistical two one by one and discuss them in the next video. Let us now look at construction of group frequency distribution. How can you construct group frequency distribution table? This is very, very important, and you ought to know the principles behind this. That of ungrouped data usually does not present challenge like these. Now, if you want to construct group frequency distribution table, what should you know? Very, very important. You see this? The class interval and the number of classes. Very, very important. As a matter of fact, the whole frequency distribution table for a grouped data depends on class interval. Once you're able to get this, your problem is solved. You can complete your table for other ones like the lower class boundary, upper class boundary, class mark, and the rest of them. Alright, now in selecting your class interval, there is no strict rule that applies to that. However, please, statisticians have shown that it is best using the range between 5 and 20. So when you are selecting, don't go and say, okay, maybe 5 to 25, 26 to 40 something. No, sometimes let the range, let it not be too narrow and let it not be too wide. So as a suggestion, between 5 to 20 is okay. Now, we're going to consider two cases, case 1 and case 2. Case 1, where one of these two items are given. Imagine you're given a distribution, then you know either the class interval or you know the number of classes, which means that you don't know one of them. What would you do? You use this formula to get the other one. Size of class interval or class weight equal to range divided by number of class intervals. The range here means the highest value in your distribution minus the lowest value. When we take a question in this, you will see how we obtain that. Alright, so that's the equation here. W here represents this, and then N here represents number of classes, this calculator N. Alright, case 2. What if you don't know any of these two? You don't know this one, you don't know this one. That is, you don't know the class weight, you don't know the number of classes. What do you do? This will help you. The Sturgis approximation will help you. Use the Sturgis approximation to calculate N, calculator N, that is number of classes. Look at the formula, 1 plus 3.322 log N base 10. This N here, small letter N, represents the number of observations. That is, how many numbers are given to you in that distribution. So you're going to use this formula to get this calculator N. Once you get the number of classes, you go back to equation 1 and then calculate your class width. Once you do that, your problem is solved. Make up the table and then complete. Let us walk through this example on the board. The score of students in an examination were 89, 54, 48, 66. Of course, continuously you see up to 68 here. Using a class size of 5, determine the number of class interval. This is one part of the question. The other part said using 5 as the number of class interval. Determine the class size. Now we're going to solve this question on the board. First, we are going to determine the number of class interval. Now, based on what they gave to us, the class size is 5. If you talk about the class size, you refer to the width, that is the class width. So our W is equal to 5. Now we are asked to determine the number of classes, so we are looking for N. Calculator N, we don't know. Now you know that for us to determine either the class size, that is class width, or the number of classes, the formula we're going to use is W equal to R all over what? N. You remember this formula? Now we are looking for N. We need to get our R, which is range. Since we are looking for N here, if we do some substitution, this is 5 equal to range, means highest number minus lowest number in this distribution. The highest number here is what? 89. So it's going to be 89 minus the lowest number in this distribution, if you look at it, is 10. So you put your 10 here divided by N. Of course, what would this give to us? We are going to have 5 equal to 89 minus 10 will give us what? 79 divided by N. To make N subject to the formula, you know, N will go this way, 5 will come here. Or you just write 5N equal to 79. So that N will be 79 all over 5. If you do 79 over 5, what will you get? You can punch your calculator on that. 79 divided by 5 is giving me 15.8 here, which you approximate towards 16. What does that mean? It simply means that if you are using a class width of 5 here, you know the smallest number here is 10. So if you start from 10, 11, 12, 13, 14, of course that 10 will not be inclusive because this is not about class boundary. So from 10, 11, 12, 13, 14, 15. So we are having 10 to 15. The next one will be 16, 17, 18, 19, and 20. So 16 to 20. If you do this, there will be 16 classes that will appear for this distribution, which means the highest number here, which is 89, will be seen in the 16th class. You know that here and these are just two classes I've shown. You can continue like 21 to 25, 26 to 30 in that order. So you see how we handle the problem. Because we know one of these two, that's why we use this formula. This time around, I want to look at the second part of the question, where we are asked to use 5 as the number of class interval and then determine the class size. Okay, so from this second part, we know the number of the class interval is given to us to be 5. We don't know the class size, that is the width or the class interval. We don't know that. And that's what we are going to calculate. And remember, if you know any one of these two, you use the formula that W is equal to range, that is class width, class size, or class interval is equal to range divided by number of class intervals. And so we're going to substitute and then see what we're going to get. W, which is class width, is not going to be, the range is 89 minus 10, that is highest number in the distribution minus lowest number in the distribution divided by what? 5. If you walk through this, your W will still give you 15.8, which is approximately equal to 16. Always remember to approximate to the highest number. What does this mean? It simply means that if the number of classes that this distribution will produce is 5, it can only be possible if the width, the class interval or class size is what? 16. We can actually verify that and see. Let's just quickly do something and see what we're going to get. The first class will start from 10, as you see, 10 to. Remember that the class interval, the size, will contain 16 digits. So if you have from 10, what will give you the 16 digits? This is how you work on that. It will be 10 plus 16. 10 plus 16 is 26. Please, you have to subtract 1 from that, and then you get 25. Why are we subtracting 1? Remember that in the 16 digits we are talking about in the class width, both this and this one, are you getting? They are inclusive in that 16. If you do the counting now, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, I've counted 15 digits, 24, and then 25, making it 16. This is class interval we are talking about. So these extreme numbers are inclusive. This is not class boundary. It is in class boundaries about lower and upper class boundaries. Since they are the boundary, you won't include them in the width. Is that clear? So that is the essence of my adding this and then subtracting 1 to get a number. Now, let us try for 26 and see. From 26, if you add, that is 26 here, if you add 16, you get 42. Subtract 1, you get 41. So it will end in 41. Then the next one, 42, add 16, 42 plus 16. Alright, let's work on that. You get 58. Subtract 1 from it, you have 57. Then the next will be 58 to add 16 to it, 58 plus 16, you get 74. Subtract 1, you have 73. Then the last, 74 to add 16 to this, 74 plus 16. You get 90. Remove 1 from it, you have 89. Do you see that if you check the number of classes, 1, 2, 3, 4, and what? 5 classes correspond to what they say. And that 5 classes in the 16 class width or interval, see that it landed you the highest point there. Sometimes it might be more than the highest number, but the point is that the highest number in the distribution will be in the last class. This is Graded Team Model Academic Enhancement School GMAT 41. You are welcome to our statistics class today. In this video, our aim is to define the terms or things that we meet in frequency distribution table, and of course how to obtain them. Because shortly after now, we are going to construct a full frequency distribution table for group data from scratch to the end. First, we start with class intervals. What is class interval? It is simply the gap between the beginning and the end number of a class. And how do you set up this class interval? You need something very important, the class size, also known as the class width. Once you're able to get a class size or class width, you can set up this class interval easily. In the previous video, we already learned how to determine the class width, either using the formula W equal to range over what? Number of classes. That W there represents our class size or class width. We explained this in the previous video. If you don't know W and you don't know your N, number of classes, you are told to use the Sturgis what? Approximation to get your N, after which you now obtain W using this formula. If you would recall, when we got in one of the examples a class width of 5 and number of class of 16, we try to set up that class interval. We had something like 10 to 14, 15 to 19, 20 to 24, continuously. Is that okay? If you had done this in that previous video, we would have gotten 16 classes just like a calculator. Now, we now want to look at our class limits after having shown you what our class interval is about. Class limit is simply the endpoint of the class interval. These are class interval. The endpoints are 10 and 14 for the first class, 15 and 19 for the second class, 20 and 24 for the third class. Now, this 10 in this first class is known as lower class limits. 14 is the upper class limit. If you come to 20 to 24, 20 is the lower class limit. 24 is the upper class limit. We are going to take a break. When we come back, we'll look at the class boundary. A very important concept where sometimes we do something that somehow seems to be reasonable but not actually correct, where we add 0.5 or you subtract 0.5 to get a class boundary of a given class. We're going to see how we actually use this to get the correct class boundary of a given class. After the break, we'll do that. You're welcome from our short break. We now want to talk about the class boundary of a given distribution. What is class boundary? It is the point of discontinuity or demarcation between any two classes. Now, if you have maybe this class in the middle now from 15 to 19, what is the point of demarcation, of discontinuation of this middle class with the one above and with the one below? So that point of discontinuation is what we call a class boundary. Now, as a matter of fact, I want to say something because in most cases we misplace class boundary with class interval. They are not the same. In class interval, the class limits, like here, 10 to 14, are included in the class interval. But when you talk about class boundary, because this is a point of demarcation, discontinuity, it is a boundary. For class boundary, the class limits there in the class boundary are not included in the given class. For example, let's assume that maybe the class boundary of this is 9.5 and that of 14 is 14.5. You know that that 14.5 will appear here in the second class as a class boundary. So that when we are counting like that 9.5 to 14.5, the 9.5 and 14.5 are not included in that class. But you notice that for class interval, like in this case 10 and 14, they are included in that class. Now the question is, how do we get the class boundary? However, take note that we have lower class boundary and upper class boundary. On the board here we have this formula that will guide us. How do you get the lower class boundary? For example, if I want to get the lower class boundary of this second class, 15 to 19, to get the lower class boundary, it's going to be the lower class limit plus the upper class limit of the class before the one I am considering, divided by 2. What do I mean by that? Let's quickly do that. You can pick your calculator and walk around as I explain this on the board. Now I want to get the lower class boundary of this second class. It's going to be the lower class limit of that second class, and the lower class limit is what? 15. Plus the upper class limit of the class before this one I'm considering. The class before this one I'm considering here is the class of 10 to 14. The upper class limit there is 14. So this is going to be 15 plus 14 divided by 2. You now get the class boundary of this, the lower class boundary of this second class. Then to get the upper class boundary, you use upper class limit of the class you are considering plus lower class limit of the class after it divided by 2. Once again, let's get the upper class boundary of this second class, 15 to 19. You would come here, equal to upper class limit of the class you are considering. The class I'm considering is the second class. The upper class limit is 19. plus lower class limit of the class after it. This plus means after it. This minus means before. So the class after this 15 to 19 class is the class of 20 to what? 24. What is the lower class limit of that class? 20. Is that not so? So you're going to do 19 plus 20 divided by what? 2. This is the actual process of getting your class boundary. It's very important, I'm saying, although in most cases it seems as if it is plus or minus 0.5. But believe me, some problems given to you, if it includes decimal, that is the distribution is a decimal number distribution, doing 0.5 plus or minus of it may just not work. This is what you need, so learn it. The next item of interest in a frequency distribution table is the class mark. And what is the class mark? The class mark is simply the average of the sum of lower class limit and upper class limit of a given class. Another name for class mark is midpoint or central value. So what do we do here? You can see the formula. You have a lower class limit of the class you want to get its class mark. Add it to the upper class limit of that same class and then divide by what? 2. For example, in the case of that 10 to 14, alright, all we need to do is 10 plus 14 divided by 2, you get your class mark. Then class size, how do we get class size? Yes, in our previous class, we had already established how to get it using the W equal to R over N formula or using the Sturges approximation if we don't know N or W. If we don't know N and W rather. However, suppose maybe a problem is given to you and the table has been given with the class interval already or the class boundary already. How do you determine the class size? You know, in that case, you don't need any formula again. You get a class size either from class interval or you get it from class boundary. Is that okay? Now, how do we do that? So there are 3 different ways you may choose. The choice is yours. Is that okay? Now we can get it from our class boundary. How? Just simply do class width equal to upper class boundary minus lower class boundary of that particular class you are dealing with. For example, in the case of that 20 to 24 class interval, for example, remember that is class interval. If I have already determined the class boundary of these two endpoints, all I will do is upper class boundary minus lower class boundary of that class, and then I will get my class size directly. So that is one way you can get your class size, also known as class width. Another way you can get it is using class limit. Alright? Come to a particular class, do the upper class limit of that class minus the upper class limit of the class before it. Or you do lower class limit of the class you're dealing with minus lower class limit of another class before it. Now what do I mean? Just imagine in the case where we had that 10 to 14 and then 15 to 19. Alright? I can simply do this class limit here, lower class limit here, minus the lower class limit of the class before it. That is this formula. Or using the upper class limit, I'll do this upper class limit minus the upper class limit of the class before this one, which is the 19 minus 14. If you do that, you see you get 5, which was actually what we obtained from our previous videos. Is that not so? If you don't want to do that, an alternative method is simply to count. Are you getting? You simply count. You come to the class limit. Come to the class limit. Like here, the class limit is 10 to 14. Then count from 10 to 14. Where 10 and 14 are also inclusive. I did that before now. 10, 11, 12, 13, 14. So you see that the class width or size will give you what? 5. In the next video, we're going to look at the cumulative frequency, that of less than and that of greater. Now, let us talk about the next item, the cumulative frequency. What is cumulative frequency in talking about our frequency table? It simply involves successive addition of all frequencies of a given distribution. Now, in this cumulative frequency, we have the less than cumulative frequency and the more than cumulative frequency. The difference is simply the direction of addition of the frequencies. Let's assume that these are frequencies 2, 8, 4, 3, for example. Alright, now if you want to get your less than cumulative frequency, which is what most of us know, you add from top to the bottom. Here you start 0 plus 2. 0 because there is no frequency before the 2. Plus 2 plus 8 plus 4 plus 3. If you do that, of course, you're going to get 17 there. And then if you're talking about the more than cumulative frequency, this one is less than cumulative frequency. For the more then, you add from bottom to the top. So 0 plus 3, 0 because nothing after 3, plus 3 plus 4 plus 8 plus 2 in that order. Now what is the importance of these two forms of cumulative frequencies? You can put this down please. Let's assume you're given a problem, maybe in a question you are asked to find a number of maybe student that sat for exam, number that scored above 80%, and maybe number of students that scored say maybe less than or below 70%. The best way of approaching that question is to convert the frequency of that distribution to less than cumulative frequency and more than cumulative frequency. If you do that, your answer will just be smiling at you there. Alright, now let us talk about our relative and percentage frequencies. These two are almost the same thing. The difference is that one is in fraction, the other one is in percentage. Relative frequency tells us the fraction of observed values that fall within a given class. By formula, we have relative frequency to be equal to the particular frequency you are dealing with. That's the meaning of that Fi. I represent a given frequency. Divided by summation, addition of all frequencies. Starting from the first frequency I equal to 1 down to the last frequency in the distribution I equal to n. For example, if I want to get the relative frequency of these two, it is simply 2 divided by the total frequency here. If you add this is 17, so it's going to be 2 divided by 17. For 8, it's going to be 8 divided by 17 in that order. And finally, the percentage frequency simply tells us the percentage of the observed value that falls within a given class. It is simply relative frequency times 100. So like in this case, now 2 over 17 you multiply by 100. 8 over 17 you multiply by 100. Please take note, the sum of all relative frequencies should give you 1. Because we'll meet something about that under probability distribution, where we'll talk about the binomial probability distribution, the Poisson probability distribution, and the rest of them. Take note. Now, if you sum all percentage frequencies, you're expected to get 100. It is now time we are set to construct a full frequency distribution table. I hope you're ready for that.